Gonna just sort of chit chat to myself for a moment while I wait for the stream to catch up. All right, so it looks like Twitch is going and waiting on YouTube. All right, excellent. We are live. Good morning, everybody, or evening, depending on where you are in the world. Welcome to the reading group. If you haven't been before, the idea is that we read a paper together. And the paper that we're going to be reading today is this paper, Language Models Are Unsupervised Multitask Learners, which from the title may or may not seem super exciting, but it is also the paper that details the model architecture for the GPT-2 model. And if you are, let's just look at the raw. If you are unfamiliar, if you haven't seen this floating around Twitter, the big thing about this model is that it can, given a prompt, produce very, well, somewhat coherent text that is expounding on that prompt and seems almost human-like. So here we have this sample, which is a little bit small. Let me make it bigger. So the sample is, he didn't use the NSA, he didn't use the CIA, he didn't use the FBI, and he didn't use the Department of Justice. He used GCHQ. What's that? It's the initials for the British Intelligence Spying Agency. As a result, Spicer posited there would be no American fingerprints on this. The British were outraged, naturally, at being accused by their closest ally of illegally spying on Trump after both the Democratic and Republican heads of Senate Intelligence Committee concluded that there were no indications that Trump Tower was subject to the surveillance by the US government. And it goes on like that. And then the completion, so one of the completions is, from the statement, they are utterly ridiculous and should be ignored. The White House did not respond to Vanity Fair's request for comment, so starting at that apostrophe. It's still not clear whether the Trump campaign was surveilled during the campaign. If so, the question of who ordered their surveillance might not matter as much as whether the surveillance was lawful. If the campaign on its own was wiretapped, then the question is whether the FBI was properly authorized to do so, said Michael German, a former senior FBI lawyer. GCHQ is not authorized to undertake electronic surveillance of American citizens, much less to tap the phones of foreign dignitaries in the United States. But as long as the FBI is investigating a crime, it can do what it needs to do to find the perpetrator. So all of this, starting after the possessive of Vanity Fairs, is generated, and there are additional completions from the same seed text using the model. So you may or may not have seen these floating around. It sounds fairly coherent. Is Michael German a real person? Michael German is in fact a retired FBI agent, so the name that's generated, which was not previously discussed in the original text, was a real person, and the discussion, the thing that they are credited as having done, it looks like he's a retired FBI agent, not a retired FBI lawyer. So it's not 100% factually accurate, but it does seem to have something like entity linking or entity understanding. Oh, one sec, let me turn that off. Sorry, that should be better. So the only thing that they have trained here is a language model. So sort of a model of which words occur close to one another in text generally. Vahid says hi. And Sanyam says, can you share your thoughts on OpenAI holding back the model release? I'm gonna hold my thoughts there until we actually read that part of the paper, just so I can see their full discussion of why they chose to do that. But yeah, I'm happy to talk about that. Anyway, so this is the model output. It's very impressive. They weren't specifically training for things like entity recognition, so knowing who people are, knowing what qualities they have. They weren't specifically training for things like co-reference resolution. It's just a language model, and the big idea of the paper that they're proposing, I think, is that you can do anything as long as you have a language model big enough. So to paraphrase Aristotle, give me a language model big enough and I can generate any text, I guess. So that's sort of the idea. There's been a lot of discussion of it, but I wanted to read the paper and see what the fuss was about. Anarchy says, hi there. Hi, Anarchy. Abstract. Oh, and I should say, this is out of OpenAI. The last paper we read, the BERT paper, was out of Google. So this is a different research group from the one whose work we've been reading more recently. Abstract. Natural language processing tasks, such as question answering, machine translation, reading comprehension, and summarization, are typically approached with supervised learning on task-specific datasets. We demonstrate that language models begin to learn these tasks without any explicit supervision when trained on a new dataset of millions of web pages called WebText. So it looks like the dataset that they're discussing might be part of the contribution of their paper. Oh, and I should say, this has not been peer-reviewed. Neither this nor the BERT paper that we read previously were peer-reviewed. They are using a new model where you release a paper and then have a bunch of PR around it. What's that? What's whooshing? Gosh darn it. Sorry, every fan in my apartment is on apparently. One sec, I'll be right back. My apologies. I don't know if it bothers anyone else, but it drives me bonkers to hear just like in the background. J.M. Romer says, hello, love your screencasts. Oh, thank you. And Niven says, any model to determine profession from a paragraph. Sorry for my English. Oh, your English is great. I think that the authors would argue that you could, that their model will learn even that, given a big enough data set. So we'll see what they say about this data set and how it was collected and what it contains. When conditioned on a document plus questions, the answers generated by the language model reach 55F1 on the COCA dataset, matching or exceeding the performance of 3 out of 4 baseline systems without using the 127,000 plus training examples. The capacity of the language model is essential to the success of zero-shot task transfer, and increasing it improves performance in a log linear fashion across tasks. Capacity of the language model is essential to the success of zero-shot task transfer. So the BERT model suggested that task-specific, adding a task-specific layer on the top is helpful, and this paper is suggesting you don't need to do that. And zero-shot, that's taking a second, that's not a great definition. Zero-shot learning is, I'm sorry, I just Googled this really quick, a form of extending supervised learning to a setting of solving, for example, to a setting of solving. For example, a classification problem when not enough labeled examples are available for all cases. Oh, here we go. Zero-shot learning is being able to solve a task despite having not received any training examples of that task. Thank you, Ian Goodfellow. So basically, we don't have any labeled training examples. We just take our model, we immediately apply it to the task, and we see the output. Ashish says, how do you select papers? Can you please consider selecting papers relevant to ongoing Kaggle competitions? So in theory, this paper suggests that this approach can be used for any NLP problem, and we have a number of NLP competitions right now. I don't know whether it would be successful or not, but the author suggests that it could be. And I am talking about this paper because it's made a big splash in the AI literature space. And Alexander says, maybe I missed it. Where was the paper published? Great question. It has not been published. So OpenAI released the paper, they released the code, they did a blog post, and they did sort of like a big PR thing, but they haven't, as far as I can tell, actually published it at any venues. And that was the same thing that happened with the BERT paper that we read last time, which is honestly, it's something I kind of feel a little squicky about. As someone who came up through the traditional academic system, the idea is that you have your paper and then it's peer reviewed by people who have deep domain expertise in whatever it is that you're working on, and they give you feedback and they're like, hey, this needs more work, or this is good, but here's some things you could improve. And these papers haven't been through this process. They have been presumably reviewed by people in the group, but not again, presumably by scholars working in the same space. So yeah, good thing to think about. Little grain of salt. Howell said, Ian just answered the question. Yeah, I figured that was a reliable source. Ian Goodfellow is a very well-known AI researcher. Okay, a little coffee. So it... blah, blah, blah. So making the language law, so it has success with zero-shot task transfer, so not having that task-specific layer that we saw in the BERT paper, and increasing capacity maybe size, the number of things that it was trained on. I'm not entirely sure what capacity means here. Improves performance in a log linear fashion across tasks. So as you make your language model better, you see the same rate of performance increase across tasks, I believe is what they're saying. Alexander says, so this is considered to be a white paper. It's not. Yeah, that's a good question. So when I say white paper, I think it's more something that's never intended to be a scholarly publication. It's more of a sort of like peer-to-peer, but no review. And this is something that I would expect to eventually be peer-reviewed. But the problem is, if you are in the NLP space and you talk to people, the likelihood that you would not have heard of this paper or the BERT paper by the time that it came to you to review is very low. So your the anonymity of the authors is not being protected, and this is a problem because we have really strong evidence from studies that if you know who the authors are and they also come from an influential lab, so like the OpenAI lab or the Google lab or Stanford, or are associated with an institution that has prestige, then that paper is more likely to be accepted than it would be if you didn't know where the authors were from. So yeah, I don't know what to call it. Maybe white paper is the phrasing we should use. Yeah. So as the model gets bigger, performance improves across all tasks. Our largest model, GPT-2, GPT-1 was the one that was discussed in the BERT paper, which is 2 LSTMs, one looking forward, one looking backwards, is a 1.5 billion parameter, holy crap, transformer that achieves state-of-the-art results on 7 out of 8 tested language modeling datasets in a zero-shot setting, but still underfits WebText. So they're suggesting it's not just memorizing everything in WebText. 1.5 billion trainable parameters is a lot of parameters. And if you're not familiar with transformers, we read the paper Attention is All You Need, Vaswani et al. 2018, that was at NeurIP, so that one is peer-reviewed. In the channel 2 papers previously. So we're sort of continuing in this line of literature. Samples from the model reflect these improvements and contain coherent paragraphs of text. These findings suggest a promising path towards building language processing systems which learn to perform tasks from their naturally occurring demonstrations. Yeah, so basically, I'm surprised they didn't call it something like language modeling is all you need to riff on the what was it? What was I gonna say? to riff on the attention is all you need paper. Yeah. John Law says, BERT is dead. Long live GPT-2. Again, neither of these have been peer-reviewed. One of the premises of BERT is that you can take their model that they've trained and tune it with relatively little training data. And they're saying you need no tuning, so that would, in theory, be better. But A, they haven't released their full language model for reasons that they discuss later on in the paper. And I don't know what the second thing I was going to say is. Yeah, keep your skepticism hats on, everybody. And that goes for BERT too. I think it's an interesting system, but remain skeptical. And that's what scientific training does for you. Okay, introduction. Machine learning systems now excel in expectation at tasks they are trained for by using a... Ooh, okay, let's start again. Machine learning systems now excel in expectation at tasks they are trained for by using a combination of large data sets, high-capacity models, and supervised learning. Krzyzewski et al. 2012, Sutsever et al. 2014, Amodi et al. 2016. Those are really old citations if you're claiming things excel right now. I don't know what excel in expectation means. Maybe that means, like, in theory, machine learning systems are good. Yet these systems are brittle and sensitive to slight changes in the data distribution. Wretch et al. 2018. I'm not familiar with any of these papers. And task specification. Kirkpatrick et al. 2017. Sorry. Current systems are better characterized as narrow experts rather than competent generalists. That's true. Generally, you are good at the domain that you're specifically looking at. Electric Riguana says, I'm sure results for downstream tasks, i.e. glue, are coming for the OpenAI 1.5 million parameter model. Yeah, I don't know if they talk about glue or not, but we will see. They talk about the benchmark, but I don't know if they evaluated against it or not. We would like to move towards more general systems which can perform many tasks, eventually without the need to manually create and label a training data set for each one. So you wouldn't need to label training data, but presumably you would still need to label your evaluation data to make sure that it's actually doing what you think that it's doing, especially for things that sound very fluent. It's good to make sure that it does the thing that you think that it does in an empirical way. That's one of my biggest problems with machine translation is when you get fluent sounding text out. So like all the little particles are in the right place, but you don't get the right meaning out, which happens less often over time as systems have improved, but it's still something that I worry about. The dominant approach to creating ML systems is to collect a data set of training examples demonstrating correct behavior for a desired task, train a system to imitate those behaviors, and then test its performance on independent and identically distributed, IID, held out examples. This has served well to make progress on narrow experts, but the often erratic behavior of captioning models, reading comprehension systems, and image classifiers, citations, on the diversity and variety of possible inputs highlight some of the shortcomings of this approach. I'm trying to think. A lot of systems are not built under the assumption that, well, I suppose it's baked into the assumption that you're going to get IID data. Yeah, I don't know that that's the dominant approach. Because I'm thinking of like Kaggle competitions, and certainly sometimes we give you data to evaluate against that has different qualities than the data that you were originally shown. So it is certainly an approach that is common. Blah, blah, blah. Okay, our suspicion is that the prevalence of a single task training on single domain datasets is a major contributor to the lack of generalization observed in current systems. Progress towards robust systems with current architectures is likely to require training and measuring performance on a wide range of domains and tasks. Recently, several benchmarks have been proposed, such as GLUE, that's what the BERT system was evaluated against, Wong et al. 2018, and DECA NLP, McCann et al. 2018, to begin studying this. I'm not familiar with DECA NLP. Let's check it out real quick. The natural language decathlon. Oh, I did hear about this. And Jer says, yeah, I agree IID is not a thing in NLP as far as I know. This has it kind of has the taste of something being written about NLP by people whose primary domain is actually ML and not NLP. Let's see, Alec Radford and Jeffrey Wu are both first authors. Let's learn a little bit more about previous work that Alec has done. Improved techniques for training GANs, proximal policy optimization algorithms, OpenAI baselines, learning to generate reviews, that's an archive preprint, archive, NeurIPS, and his specialization areas are deep learning and machine learning. Has he ever been published at an NLP conference? Not that I can see. Okay, so definitely Alec is an ML person and not an NLP person. And Jeffrey Wu is a much more common name. Actually, the easiest thing might be to... Oh, he's written a paper with Ian. Looks like they haven't previously collaborated. Princeton, Stanford, Georgia Tech, statistics. Okay, I don't know who of these things it is. Okay. Blah 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 blah. It's the Soaker Glue, Electric Iguana says, of the decathlon. And Jeff Wu is from industry, SE expertise, software engineering, I'm assuming, which makes sense given that a large portion of the paper was a dataset advance. This page has nothing on it. Okay, and I don't think I know any of these folks. I'm not saying I know everybody in NLP, but I tend to know, the big names. So this, there might be some sort of not super NLP things in here. We'll see. Okay. So single task training they're suggesting is a problem because it makes your systems non-generalizable. Progress towards robust systems with current architectures is likely to require training and measuring performance on a wide range of domains and tasks. Oh, wait, we already read that. And DECA NLP, the NLP decathlon. Multitask learning is a promising framework for improving general performance. However, multitask training in NLP is still nascent. Recent work reports modest performance improvements, and two of the most ambitious efforts to date have trained a total of 10 and 17 dataset objective pairs, respectively. So multitask learning is where you learn to do many things together at the same time. I think there was, the ACL, one of the ACL best papers in 2017 maybe, was on multitask learning for image labeling and caption generation. So it's been a thing in NLP for a while. I'll find that paper if people are actually interested. But they're suggesting that you need to have many tasks that you're learning together for effective multitask learning. From a meta-learning perspective, each dataset objective pair is a single training example sampled from a distribution of datasets and objectives. Okay. Current ML systems need hundreds to thousands of examples to induce functions which generalize well. So they're saying that 10 or 17 tasks are not going to be enough. You're going to need to train across hundreds or thousands of tasks at once in order to induce functions that generalize well. So if we're trying to map the entire space of data sets that you might have, and also objectives that you might have given a specific data set, so things like machine translation or parsing or co-reference resolution or whatever, then you need to have a large sample of both and the links between them. I'm assuming these are conditionally probable. Hopefully they'll get into that. In order to figure out sort of general NLP functions. That's not something I'd say probably, but also I wouldn't have written this paper, so. This suggests that multitask training may need just as many effective training pairs to realize its promise with current approaches. It will be very difficult to continue to scale the creation of datasets, that's an understatement, and to design objectives to the degree that may be required to brute force our way there with current techniques. This motivates exploring additional setups for performing multitask learning. Okay. The current best performing systems on language task use a combination of pre-training and supervised fine-tuning, which is what BERT did. And I guess you could also say that using pre-trained embeddings is sort of the same thing. This approach has a long history with a trend towards more flexible forms of transfer. First, word vectors. Yeah, that's what I just said. I should read the paper instead of saying the things that I think that they're going to say. Word vectors were learned and used as inputs to task-specific architectures. Makalov et al. 2013, Colabert et al. 2011. I feel like these are non-canonical. I haven't done a whole lot of work in the word vector space, but I don't think these are the usual citations for that. Also, they're doing the thing where they're LaTeX. They've forgotten to put all of the citations together in the same set of parentheses, and each citation is in a different parenthesis, and it's driving me. It's very annoying to me in a very unreasonable way. So Jay says, Rachel, I need to know how to live stream tweets, and it should update the dashboard in the R language. Not quite the time for me to take the time to answer that, but I would look into Shiny. Okay. The contextual representations of recurrent networks were transferred. And recent work suggests that task-specific architectures are no longer necessary, and transferring many self-attention blocks is sufficient. So this is the BERT model that they're using. These methods still require supervised training in order to perform a task. When only minimal or no supervised data is available, another line of work has demonstrated the promise of language models to perform specific tasks, such as common sense reading, Schwartz et al., and sentiment analysis, Radford et al. Radford is this guy. So he's citing his previous work. Oh yeah, that's right. This is the GPT model, so the original one, and not the second version that they're doing now. And Schwartz et al. I'm not familiar with this paper. 2017. Story close task, UW NLP system. That must be this. Smith NA must be Noah Smith from UW NLP. Sorry, that's where I went to grad school, so I'm fairly familiar with it in proceedings of the second workshop of linking models of lexical, sentential, and discourse level semantics. Interesting. I'm not familiar with this paper, but I believe that they have read them. Oh, they're citing preprints. If it's been published, cite the publication venue. Sorry. These are things that, were I reviewing this paper, I would be writing in my review. But again, they didn't, as far as I know, submit this to a publication venue, so perhaps it's unfair to be evaluating them on those criteria. In this paper, we connect those two lines of work and continue the trend of more general methods of transfer. We demonstrate language models can perform downstream tasks in a zero-shot setting without any parameter or architecture modification. We demonstrate this approach shows potential by highlighting the ability of language models to perform a wide range of tasks in a zero-shot setting. They said the same sentence twice. We achieve promising, competitive, and state-of-the-art results depending on the task. Interesting. So they're going to say we did okay, we did good, and we did the best in order. Interesting. Approach. At the core of our approach is language modeling. Language modeling is usually framed as unsupervised distribution estimation from a set of examples, x1 through x sub n. Each composed of variable length sequences of symbols, s1 through sn. Since language has natural sequential ordering, it is common to factorize the joint probabilities over symbols as the product of conditional probabilities. The parentheses in between the citations. So P of X is the big pi. People help me say the math words, please. So you're taking the conditional probability across the probability of a certain sequence given symbol given all of the other symbols, except for the one that you're on currently. So basically you look at all the current symbols in your sequence and you do a conditional probability across all of the examples you have seen previously. Is that correct? I think so. Let me know if that isn't correct. This approach allows for tractable sampling from an estimation of P of X, as well as any conditionals of the form P of S n minus k to Sn given S1 to Sn minus k minus 1. Jared says, given all the previously seen symbols. Thank you. So I can continue to generate symbols in front of the ones that I have seen previously, given all of the ones that I have seen previously. It says, easier to say this, circulating the formula, than trying to read it. In recent years, there have been significant improvements in the expressiveness of models that can compute these conditional probabilities, such as self-attention architectures like the transformer. Yeah, so previously, sort of like the former state of the art for things like language models were hidden Markov models. So I guess originally it was n-grams, and then it was hidden Markov models, and now we have more easily trainable more parallelizable, wow, let me take another little sip of coffee, ways of learning the same probability distributions. Although my understanding is, and it's a little bit shaky because I'm still working on it, my understanding is that BERT in particular is not actually learning the conditional probabilities, is what I've been told. I might need to go back and review my notes. Okay. Learning to perform a single task can be expressed in a probabilistic framework as estimating a conditional distribution probability of the output given the input. Since a general system should be able to perform many different tasks even for the same input, it should condition not only on the input but also the task to be performed. That is, it should model the probability of the output given the input and the task. This has been variously formalized in multitask and meta-learning settings. Task conditioning is often implemented at an architectural level, such as the task-specific encoders and decoders in Kaiser et al. 2017, or at an algorithmic level, such as the inner and outer loop optimization framework of MAML. I have no idea what MAML is. Let's see, Fin et al. 2020. Model agnostic meta-learning for fast adaptation of deep networks. Never heard of this. 2017. Was it published anywhere? Yes, it's in the Proceedings of MLR. I don't know. Tell me more about this paper. International Conference on probably machine learning research, actually. which would make sense why I haven't heard of it, because I tend to circle the what are they called? The ACL conferences, which are more NLP focused. So it's out of Berkeley. It was at ICML 17 in Australia. And let me make this bigger. So in that paper, we propose an algorithm for meta-learning that is model agnostic in the sense that it is compatible with any model trained with gradient descent and applicable to a variety of different learning problems, including classification, regressment, and reinforcement learning. Classification, regression, and reinforcement learning. The goal of meta-learning is to train a model on a variety of learning tasks such that it can solve new learning tasks using only a small number of training samples. In our approach, the parameters of the model are explicitly trained such that a small number of gradient steps with a small amount of training data from a new task will produce a good generalization performance on that task. In effect, our model trains the model to be easy to fine-tune. We demonstrate that this approach leads to state-of-the-art performance on 2 few-shot image classification benchmarks, produces good results on few-shot regression, and accelerates fine-tuning for policy gradient reinforcement learning with neural network policies. Okay, so what they're proposing is a way to take an existing model and more quickly move through gradients. Yeah, so it's sort of like you take your model and you put it on roller skates and it moves with lower friction and more quickly so that it's faster to tune. Osmond says, hello. Vahid said, so it's not agnostic of the model, it must be gradient descent. Yes, correct. An Electric Iguana says, BERT's objective doesn't allow for typical text generation because it relies on having forward context rather than just conditioning on previous symbols. Because it's filling in the blanks rather than predicting the next word, you can't do conditional text generation. So like you said, the conditional probability for LM in this paper doesn't apply. Thank you. That was very helpful and succinctly put. It says, I wonder if they took that approach, so to go with mammal to get the good acronym for it. Yeah, I don't know. Where were we? Further up than that. There we go. Okay. So mammal is an approach to move an existing model more quickly by learning about learning. But as exemplified in McCann et al., language provides a flexible way to specify tasks, input, and outputs, all as a sequence of symbols. This seems like a sentence written about language by someone who is a machine learning researcher. This is not how a linguist would talk about language, but I don't think it's necessarily wrong. Osman says, what's the best starting resource for learning data science? I am a beginner. I would maybe go through the Kaggle Learn material, which is, I think, kaggle.com/learn. I would say that this is what we're talking about here is a little bit more advanced. For example, a translation training example can be written as the sequence translate to French, English text, French text. Likewise, a reading comprehension training example can be written as answer to question, document, answer the question, so this is the task, translate to French is the task, document, question, answer. So you have 4 inputs here. 1 is the task, 3 are part of the data set. This has 3 parts, 1 is the task, 2 are the data set. McCann et al. Demonstrate that it was possible to train a single model, the MQAN maybe, to infer and perform many different tasks on examples with this type of format. So this must be McCann et al. 2018. McCann et al. 2018, and it's pointing to archive. Was it published? So McCann did learned in translation, contextualized word vectors at NeurIPS, and also the decathlon. Okay, so that's why the name is looking familiar. It's the same researcher who did both. Was this published anywhere? Okay, yes, and it was published in Europe as well. And it's basically saying here's what worked good for images. Will it work good for text? Initializing multiple deep layers with weights pre-trained on large supervised training sets like ImageNet. Natural language preprocessing typically sees initialization only at the lowest layers of deep models with pre-trained word vectors. In this paper, we use deep LSTM encoder from an attentional sequence-to-sequence model trained for machine translation. Attentional sequence-to-sequence. I wonder if that's a transformer. To contextualize word vectors, we show that adding context vectors, COVE, improves performance over using only unsupervised word and character vectors on a wide variety of NLP tasks. Have I read this paper? This looks fairly familiar to me. Maybe they talked about this in BERT. COVE employs contextualized word vectors. Context vectors, sorry, is definitely something that I have heard discussed previously. Maybe I read a blog post about this paper. Anyway, so the idea here is instead of just vectors, you have vectors with the context of the word. So you add a little sprinkle syntax, just a little tiny bit on top. And now I have to scroll back up. Okay. McCann et al. Demonstrates that it was possible to train a single model, the MQAN, to infer and perform many different tasks on examples of this type of format. What? I don't think that's what they propose in this paper. Did I just like miss it? MQAN. QAN. Yeah, that's not in here. I think this citation is wrong. Ryan says, COVE is an important paper. I haven't read it, but it's been talked about a lot. And Jer says, if you are looking into more practical... Oh, sorry, that's continuing to reply to Osman, thanks, Jer. And Krav had a question about CNNs, which are a little bit off topic for this particular paper. So jump into the chat if you've got an answer for Gaurav. Okay. It was McCann 2018. Oh, so maybe it's actually the decathlon. Okay, I think I looked at the wrong paper. All right. Has this been published? It was put on open review, which does not necessarily mean that it was accepted anywhere. Looks like not. So this has also not been published. And the natural language decathlon. So the thing that they presented was a multitask question answering network, MQAN, jointly learns all tasks in DECA NLP, so presumably the 10 tasks that they're talking about, with any task-specific modules or parameters in a multitask setting. MQAN shows improvements in transfer learning for machine translation and named entity recognition, domain adaptation for sentiment analysis and natural language inference, and zero-shot capabilities for text classification. Interesting. So again, like with the paper we're reading currently, they're sort of like, it's okay on some things, pretty good on other things, and really good at some other things. Interesting. I'd be interested to see if the things that they had really good outputs on are the same things that the GPT-2 paper has good outputs on, because that might suggest that some tasks are more amenable to this particular type of modeling than others. As it turns out, language is complex and special, and you can't just solve it with math. I like to believe in my heart. No, that's not fair. I think you can solve language with math. I don't think you can solve language just by dumping it like a box of Legos into a Lego sorter. We just demonstrate the MCAN's multi-pointer generator decoder is key to the success, and performance further improves with an anti-curriculum training strategy. The design for DECA NLP MQAN also achieves state-of-the-art results on the WikiSQL semantic parsing task in a single task setting. We also release code for procuring and processing data, training and evaluating models, and reproducing all experiments for DECA NLP. Good job sharing the code. And the 10 tasks in DECA NLP are question answering, machine translation, summarization, natural language inference, sentiment analysis, semantic role labeling. Semantic roles are things like agent, patient, instrument. So the agent is the entity that's performing actions in a sentence. The patient is one that is having actions performed on them. The goal is the place that you want to go to. So not every sentence is going to have all semantic roles. Zero-shot relation extraction. I'm not entirely sure what relation extraction is. I'm not super familiar with this task. Goal-oriented dialogue. So this would be like, make a reservation, and it makes a reservation. Semantic parsing and common sense pronoun resolution. Pronoun resolution is what the current gender bias competition on Kaggle is around. What was the one that I was going to look at? Relation extraction. I'm not super familiar with this goal. And presumably they're going to talk about their performance on this particular task. So I think it is informative. It's an established task. Thank you. The detection and classification of semantic relationship mentions within a set of artifacts, typically from text or XML documents. Oh, okay. So it's like Barney is from Peru, and you want to be able to have the relationship is from between Barney and Peru. Okay. Ryan says, this is interesting to see because you're digging into the sources much more than I typically do. It's more because I'm not as familiar with this literature. So I think I mentioned that papers are like ongoing conversations, and this is a conversation that is happening in a room full of machine learning researchers and not a room full of NLP researchers specifically. Okay. Scrolling to where I was. Oh, here we are. We were talking about MQAN. Language models are also able to, in principle, learn the tasks of Mechanidal, so the decathlon that we just talked about, without the need for explicit supervision of which symbols are the outputs to be predicted. So that would be like in this particular example, you'd be able to answer the question given the document in the question, but you wouldn't need to specify the answer, I think is what they're saying. Since the supervised objective is the same as the unsupervised objective, but only evaluated on a subset of the sequence, the global minima of the unsupervised objective is also the global minima of the supervised objective. Well, subset of the sequence. So they're saying because supervised is more complex, the unsupervised version of it is... So the supervised objective is a more complex version of the unsupervised objective, and the decision space overlaps where it's important, i.e. the global minima. In this slightly toy setting, the concerns with density estimation as a principled training objective is discussed in Sutzkever et al. 2018, are sidestepped. In this slightly toy setting, the concerns with density estimation as a principal training objective discussion Sutzkever et al. 2015, are sidestepped. And you should not have parentheses when you're citing in text. The problem instead becomes whether we are able to, in practice, optimize the unsupervised objective to convergence. Preliminary experiments confirm that sufficiently large language models are able to perform multitask learning in this toy-ish setup, but learning is much slower than in explicitly supervised approaches. So people have been able to do it previously, but it's taken a really long time. It's sort of wandered around the decision space. We've taken a bit to get to the point where we actually converge. And you do finally get there, but it is faster if it's supervised, is the previous findings that they're suggesting. Well, it is a large step from the well-posed setup described above to the messiness of language in the wild, Weston 2016 argues. In the context of dialogue, for the need to develop... Whoa. Okay, let's take this one from the top. While it is a large step from the well-posed setup described above to the messiness of language in the wild, Weston argues, in the context of dialogue, for the need to develop systems capable of learning from natural language directly and demonstrated a proof of concept learning the QA task without reward signal by using forward prediction of a teacher's outputs. What? Okay, so language in the wild, quote unquote, is different from this toy example. Weston suggests that in dialogue, we need to develop systems that can learn from natural language directly, so unlabeled language, and has the proof of concept learning a QA question answering task without a reward signal, so not saying if it's correct or not, by using forward prediction of a teacher's outputs. So training on what a teacher says? But then wouldn't the reward signal be doing the thing the teacher did? Or maybe the teacher isn't a separate entity. It's part of the system? I'm confused. Maybe it's like oracles? I have learned about oracles at some point in the past. No, not... No, that's not what I don't want to learn about oracles work on NLP. I want to learn about oracles in NLP. There we go. A oracle is somebody who already gives the right example. An oracle experiment is used to compare your actual system to how your system would behave if some component of it always did the right thing. So I think that's what I'm thinking they are saying when they say teacher, but it might not be. I'm confused about this whole thing. While dialogue is an attractive approach, we worry it is overly restrictive. The internet contains a vast amount of information that is passively available without the need for interactive communication. Okay. So I think what they're doing in this paper is I think that they have part of a dialogue and they are predicting what the next turn in the dialogue is going to be, and the reward signals how close you are to that. So the so you don't need to have labeled input, but you do need to have sequential input. Okay. That's all. It's making sense now. The internet contains a vast amount of information that is passively available without the need for interactive communication. Our speculation is that a language model with sufficient capacity will begin to learn to infer and perform the tasks demonstrated in natural language sequences in order to better predict them, regardless of their method of procurement. So just sort of like a general purpose language knower that will be able to do different tasks. If a language's model is able to do this, it will be, in effect, performing unsupervised multitask learning. We test whether this is the case by analyzing the performance of language models in a zero-shot setting on a wide variety of tasks. Okay. Training data set. We'll probably get part of the way through here. I don't know where this figure belongs. Section 3 apparently, and we are just starting section 2 now, so there's some law tech excitement that happened there. Okay, training data set. Most prior work trained language models on a single domain of text, such as news articles, Wikipedia, or fiction books. It's weird citations for that, but okay. I probably would have cited things like COCA or the British National Corpus, but something tells me these researchers may not be super familiar with the corpus work. Our approach motivates building as large and diverse a data set as possible in order to collect natural language demonstrations of tasks in as varied of domains and contexts as possible. So they're getting a big sample, it's got a lot of stuff in it, and it's lots of different stuff. A promising source of diverse and nearly unlimited text is web scrapes such as Common Crawl. While these archives are many orders of magnitude larger than current language modeling datasets, they have significant data quality issues. That's an understatement. Trin and Lee 2018 used Common Crawl in their work on common sense reasoning, but noted a large amount of documents whose content are mostly unintelligible. We observed similar data issues in our initial experiments with Common Crawl. Trin and Lee 2018's best results were achieved using a small subsample of Common Crawl, which included only documents most similar to their target dataset, the Winograd Schema Challenge. Schema Challenge? Schema Challenge. While this is a pragmatic approach to improve performance on a specific task, we want to avoid making assumptions about the task to be performed ahead of time. Instead, we create a new web scrape which emphasizes document quality. To this, we only scraped web pages which have been curated/filtered by humans. Manually filtering a full web scrape would be exceptionally expensive, so as a starting point, we scraped all outbound links from Reddit, a social media platform which received at least 3 karma. This can be thought of as a heuristic indicator for whether other users found the link interesting, educational, or just funny. Oh, interesting. Okay. The resulting dataset, WebText, contains the text subset of these 45 million links. To extract the text from HTML responses, we use a combination of Dragnet, Peters and Lecoq, 2013, and newspaper content extractors. And there's a GitHub link to the extractor they used, but only one of them. All results presented in this paper use a preliminary version of WebText which did not include links created after December 2017, and which, after deduplication and some heuristic-based cleaning, contained slightly over 8 million documents for a total of 40 gigabytes of texts. We removed all Wikipedia documents from WebText since it is a common data source for other datasets and could complicate analyses due to overlapping training data with text evaluation tasks. Where does table 1 pop up? Is it ever referenced in the text? It looks like it's not. So let's just read the text. Nope. Oh, nope, it's from the translation. Interesting. So some thoughts that I have right away. So Reddit tends to have communities that form around specific topics. I don't know if y'all use Reddit or not, but they tend to have narrow domains. So I think that there's probably a pretty uneven distribution of genres across their data set. So I imagine they're going to have more news text than, let's say, fiction. They're probably not going to have a whole bunch of fiction text. They removed Wikipedia, which I think makes sense. And also I imagine there were a fair number of Wikipedia links available in the text, so it probably also reduced the full size of their data set, which is already pretty large for a text data set. About 8 million documents, which is a fair number. I'm hoping they're going to talk about, and I don't think they will, the domains that they come from, the languages that they come from. It looks like they have some code switching, some multiple languages being used together. Yeah, there could be pretty strong content biases here. So I noticed that a lot of their samples were sort of news related, so it's possible that it might not extend as well to other domains. Yeah, Electric Iguana says it was filtered down to English only. Okay, that's good to know. Wait, but then how are they doing translation? Where's this coming from? Well, hopefully they'll mention it. Also, I have worked with, if it was automatically filtered, I've worked with language identification algorithms quite a lot, and they don't tend to work very well on text that is, what's the word I'm looking for? Informal, noisy user-generated text is the phrasing people tend to use a lot in the NLP literature. So, for example, Brandon O'Connor and his student whose name is slipping out of my head right now, had a paper at, I think, EMNLP a minute ago showing that African American English noisy user-generated text, specifically tweets, was often incorrectly identified as Dutch. If you've used Twitter's language identification, it is very happy to hallucinate Malay in particular. Yeah. JR says, I saw a video of GPT-2 earlier, and I remember that the huge majority of language comes from English. 10 megabytes are French. Okay, that's good to know. Hopefully they'll talk more about it. Nope, that's it. That's what they have for the data set. Maybe they talk more about it further down? Well, we'll get to it next week. Electric Iguana said, performance on this task, and this is a quote, was surprising to us since we deliberately removed non-English web pages from WebText as a filtering step. Didn't mention that in your datasets, what's it called, section, please. Please tell me all the pre-processing you did. That's really important. In order to confirm this, we ran a byte-length level language detector on WebText, which detected only 10 megabytes of data in the French language, was approximately 500 times smaller than the monolingual French corpus common in prior unsupervised machine translation research. Byte-level language detector? Interesting. I also am interested about what they did about characters. Oh, okay, so it looks like they talk a little bit about characters here. Okay, I'm gonna wrap it up here because it is 10. I don't want this to go much over an hour. I have so many questions. I think it's an interesting approach. As someone who has obviously invested a lot of time in the idea that language is special, I don't love the idea that you can just throw a bunch of spaghetti at a wall and sometimes it makes a mural. But we'll see. We'll see as we read the paper, other things that they discuss, their model architecture, which I'm imagining is going to be the bulk of this paper and the thing that they're most particularly interested in. I don't know, I might reach out to the author, see if we can get a chance to chat. Yeah. All right, I'm gonna wrap it up here. I will be back on Friday for live coding. I'm not 100% sure what I'm gonna do. I have some ideas, but we'll see what I feel like on Friday. So I'll see you there if you come and join me then. Otherwise, I will be back next Wednesday, I'm pretty sure. I do have some travel coming up, so I'm going to try and figure out how I can keep doing this live stream while I'm traveling. I might switch the day that it is, which I know isn't ideal for folks, or do it at a different time, or I don't know. I'll figure it out. I'll let you know as it comes up, and I will talk to you guys soon. Thanks for joining. Bye.